Alright guys, so today we're beginning our next section. So remember in the last section we started playing with the idea of the rate of change. Well, we're going to begin now calling that rate of change more of called slope. Slope is just more the mathematical term. If you guys look on the screen, slope is just another word that is used to describe the steepness of a line or the rate of change of a linear relationship. So let's begin. On the screen right here I have 4 different equations. If you look on the right, you can see that they're all linear functions. Why? Because they all pass the functions test. So for example, sorry about that little crazy line going all over the place. If I'm going to do my vertical line test, I can clearly see that all 4 lines pass the vertical line test, so they're all functions. So I know that each of these have a rate of change, or in other words, today we're going to call that slope. Don't forget to be whisking this video in your notes, and then I will check it tomorrow in class when you guys come back. Remember, you're watching, you're summarizing, and you're questioning. Today's slope, for those of you that had me last year, slope is really defined as the change in y over the change in x. This triangle right here on the screen next to the y and this triangle next to x literally means delta. So if you want to think of it as delta y over delta x, delta is just the Greek symbol for change. So it's change in y over change in x. If you remember the story from last year, for those of you that had me, I always talked about Delta Airlines. Their first logo was Delta Airlines, the change in the way we fly. So it's pretty cool how it works. In class, we introduced the idea that slope in y-intercept form. Here's y-intercept form. Y is equal to a plus bx, where the coefficient of x this time is b. That's my slope. So you can think of it as today. B is also the same as the change in y over the change in x. It doesn't matter if you use m or b, just know that it just stands for slope. The first method of finding slope, if they're giving you a graph, it's called the slope triangle. The slope triangle is really mean the rise over the run. But sometimes we have a negative slope, so it's really the rise or fall over the run. So remember, it's the change in y over the change in x. If you want to think in literal sense, it's rise over run. So here I have a function. There's no units, so just look on the screen. I am going to go up, and then I am going to run to my next point. The slope is, we can find slope with just given any 2 points, and the first easiest way is to use the slope triangle. Here's the first example. Using the slope triangle, find the rate of change of this function. If you want to pause the video and try the slope triangle now, that's fine. If not, just watch what I do. So here's my first point that they give me. Each of these units on the x-axis is 1 unit. Each of these units on the y-axis is also 1 unit. So I know that I'm going to rise, draw my triangle. It's okay if you go all the way up, do a vertical line. Totally fine. And then watch what I do. What I do is I just, from my other point, I'm going to connect it to my blue line. And I've created this triangle. So really, I can erase this, and I can clearly see that I have a steepness or a step, so I have a slope. So all we do is we count the rise. From here is 1 jump, 2 jumps, 3 jump, 4. Going up is positive 4. And then from this corner to the other point, 1, 2. So moving on the right to the right direction of my x-axis is also positive, so plus 2. And slope is defined as the change in y over the change in x. So I know that the change in y was positive 4. I can see that from my drawing. And the change in x is plus 2. So I simplify that down to my slope is 2 over 1. Or just 2. And that's how you use the slope triangle. Do it this way at first. It's going to be weird if you haven't found slope at all. For some of you, this is just review. Next, I'm going to introduce the slope formula. So the slope formula, if you go back to the last slide, the change in y from one point to the other, and then the change in x from the other, it pretty much means to find the common difference. So here on the screen is the formula for slope that you guys will encounter in Algebra 1, in geometry, in advanced algebra, and so forth. This formula for slope never changes, but really, I'll write it one more time. Slope is defined as delta y over delta x. You can really think about it. If I have two coordinates on the same line, it's really y sub 2 minus y sub 1 over x sub 2 minus x sub 1. If you clearly look on the screen right here, y sub 2 minus y sub 1, that's my delta y. That's how I find the change. And my x sub 2, take away x sub 1, that's my change in x. So there's your formulas for slope. Make sure you write that down in your notes and your WIS sheet because we will practice this a lot over the next couple weeks. There are 4 types of slope. You can clear on the first example with the slope triangle. When I go up and to the right, that's called a positive slope. Why is it a positive slope? Because the change in y and the change in x are both positive. If you can think of a positive slope as a direct variation. As my x increases, so does my y. Vice versa. In this case, as my y increases, so does my x. The second type of slope is the inverse of that, is a negative slope. You can clearly see that the line is going down from left to right. It's like going down a hill. That's a negative slope. Why? Because the change in y is positive, but the change in x is negative, or vice versa. As the change in y is negative, the change in x is positive. That's called the negative slope. Regardless if you're not sure about a positive or a negative slope, just go back to the slope formula and do it mathematically, and you'll just remember to carry the symbol. Here are 2 different other slopes that you will see. This one is kind of like our walking graph where I'm standing still, not really moving anywhere, but time's still passing. So since I'm not walking anywhere, I can say that my rate of change, or in this case, my slope is 0. Next, this is something that's really weird when you divide by 0, which cannot happen. So this slope is called undefined. We'll talk more about undefined slope in class, but just know that whenever you divide by 0, you get an error message, and that means undefined. Next, we're going to go over how is slope related to slope-intercept form. Well, in the last section, all we did was talk about rate of change. You have to understand that slope and rate of change is the same. Remember that today, whenever you see y equals a plus bx, it's pretty much the same as y equals mx plus b. Okay, where b and m they're the same. They both mean slope. They both mean the rate of change. We rarely say find slope, because slope is just using, it's a mathematical term to describe the steepness of a line or the rate of change, but just know that it really all means the rate of change. So here's another example. Given the 2 points, find the slope and name another point on that line. This is a very common question. So first thing I need to do is I need to find the slope. So to find slope, you can use the slope formula. The slope formula, again, is m is equal to y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. When I'm given 2 points, the first thing I want to do is go in there and organize my information. So I'm going to go left to right. This is x1, y1, x2, y2. And then I just put it into the formula. So I know that y sub 2 is 7 minus y sub 1 is 4. Divided by x sub 2 is 4 minus 2, and I just do the mathematical operation. 7 minus 4 is 3, and 4 minus 2 is 2. 3 halves. I can't reduce that anymore. Remember how I said Mr. Wynn's anti-decimal? So do not put it into a decimal. Leave it as an improper fraction, and my slope here is 3 halves. What does this 3 halves means? For every change in y of 3, positive 3, x goes up by 2. So when you need to find another point, just create a quick t-table. Looks something like this. X, y, I'm going to put in my points that they give me, 2, 4, 4, 7, and my slope is 3 over 2. Common misconception here. You think that x is changing by 2 and then y is changing by 2. No, remember that slope is defined as delta y over delta x. So 3, that positive 3 really means y is moving up by 3, moving up by 3. So the next one's going to be 10. X is going up by 2. Do another positive 2. And I know that another point on the line is going to be 6, 10. Okay, that's how you use the slope formula to find another point on that line. So we're going to put it all together. Consider the line goes through the point 1, 7, and 6, 4. So I know that this is 1, 7, and 6, 4. Right away, I hope you know that this is a negative slope, because you can see that as my x value is increasing, my y value is decreasing, so it's a negative over a positive, so that's a negative slope. So let's practice using the slope triangle. Just go straight down, go straight across to build your slope triangle, and that's going to be a 1, 2, 3, negative 3 drop, and then 1, 2, 3, 4, 5. That's a positive 5. So the slope is delta y over delta x, which means the change is negative 3 over 5. So this idea about how about we build a triangle the other way? What if I wanted to stick to the rise over the run, or the run over the rise? So this time I'm going to build a triangle like this. Okay, remember it's rise over run, so it's 1, 2, 3. That's a positive 3. And then when I go 1, 2, 3, 4, 5, you see how I'm moving from right to left on the x-axis, so my x value is decreasing, so that's a negative 5. So again, I get positive 3 over negative 5. Both of these are negative 3/5. It doesn't matter where the negative symbol is. They're both negative 3/5. So that's one way to find the slope. If you want to challenge yourself, go ahead and find the slope using the 2 points without using the slope triangle. I'm not going to do that right now. We'll do more of that in class. But just know that there's a couple different ways to find slope, and that's one way. So my slope right now is negative 3/5. Without graphing, verify that the point 4 and 5 and 2/10 is on the line. This one's a little trickier because it's not a whole number. So if I go to my x value is 4, I go up, yeah, it looks about 5 and 2/10. But what we know is that if we use 2 points on the same line to find slope, that the slope is the same for all of the points on that line. So let's just use the slope formula to verify the point 4 and 5 and 2/10 are on that line. So what I know is my first point right here is 1, 7, and this is 6, 4. I'm going to go ahead and just use this first one. Again, this is x sub 1, y sub 1. I'm going to go here and say this is x sub 2, y sub 2. So y sub 2 is 5.2 minus 7. And then my other one is going to be 4 minus 1. And I should get 4 minus 1 is 3. 5.2 minus 7. If you don't know how to do that, that's totally okay. Go ahead and use your calculator. So 5.2 minus 7. I get negative 1.8. What does this mean? Well, if you go back to your calculator, and I get negative 1.8, go ahead and change that into a decimal, divided by 3. I get 0.6. Why do I need to know that? Why do I need to know this decimal value? Because I know that negative 3 divided by 5 will give me also negative 0.6. So which means both decimal values are the same, which means I can simplify this down to negative 3/5. So because both give me a decimal value of negative 6/10, you will say yes. 4 and 5 and 2/10 is on this line because they both have the same slope. Okay, the last question is find the coordinates of another point on the same line. Well, and if I know my slope is negative 3/5 and I know this point for sure is 6, 4, well, just do the little quick t-table if you want. You know that y is going down by 3. So 4 minus 3 is going to be 1. X is going to be increasing by 5. So 6 plus 5, 11. So another point on this line is going to be 11, 1. So the question is 11, 1. And what is my slope? Negative 3/5. And that's how you do those, how you find slope using the slope formula and slope triangle and verifying other points on that line. We will practice this a lot in class the next couple days, so make sure you whisk this video, have your notes handy, and I will check it